All right, let's talk about something you probably never think about. The wires that bring TV and internet into our homes, and how they can create some serious, invisible chaos in our very wireless world.
Okay, let's just jump right in with a question that sounds, well, kind of nuts. Could the simple coaxial cable that's plugged into your TV actually put an airplane in danger? It sounds like something out of a movie, right? But the answer is a resounding yes.
And look, this is not a hypothetical. This really happened. Back in 1976, near Harrisburg, Pennsylvania, pilots started reporting some really scary radio interference. As they were on final approach, their radios were just filled with all this noise, making it incredibly difficult to hear air traffic control. So the FAA and the FCC launched an investigation, and what they found was just wild. The culprit was the local cable TV network. Little leaks in the system were basically acting like antennas, blasting out interference that reached thousands of feet into the sky.
So, how in the world does a system that's just supposed to bring you shows and internet cause so much trouble? To get that, we need to understand how these cable networks are supposed to work and what happens when they break.
I want you to picture a garden hose, a really good one with no holes. That's what a cable TV network is supposed to be, a totally closed system. All of those signals, all those channels, your internet connection, everything is meant to stay inside that shielded cable, completely sealed off from the outside world.
But, when that perfect seal gets a crack, two things can happen. The first is called signal leakage, or egress. That's when the signals inside the cable escape out. The flip side of that is ingress, and that's when outside radio signals get into the cable. Now, both are a problem, but today we're really focused on egress, that invisible threat leaking out. And what's crazy is that it doesn't take much. We're not talking about a construction crew cutting a line in half. A tiny, tiny crack in the cable's outer shield, that's all it takes to turn that closed system into a little radio antenna.
So what causes these breaks? Well, it's usually the boring, everyday stuff. Connectors that get a little loose or rusty over time. The cable itself getting scraped up against a tree branch, or maybe a squirrel decides to chew on it. It could be an amplifier case that's warped in the sun, or even just a part that wasn't installed quite right. Any one of these little things can create a leak.
Now, because of what happened in Harrisburg, for decades, the number one worry about these leaks was all about one thing: aviation safety. After that Harrisburg incident, the FCC made it really clear what their priority was. Their biggest concern, their whole focus, was preventing any interference with airplanes. The idea that a TV signal could mess with a pilot's ability to talk to the tower or navigate, that was the absolute worst-case scenario.
And they zeroed in on this very specific slice of the airwaves, from 108 to 137 megahertz. This little section of the radio spectrum is sacred ground for airplanes. It's where they talk, it's where they navigate, so protecting this band became the whole point of cable leakage rules.
And that led to some really strict regulations. Cable companies had to drive around and scan their entire network for leaks every 3 months. If they found a leak stronger than 20 microvolts per meter, which is super, super tiny, they had to fix it. And once a year, they even had to hire a plane to do a flyover and measure the total radiation coming off their whole system from the sky.
And for a long, long time, this system seemed to work just fine. But then, our world changed. And the sky, well, the radio sky, it got a whole lot more crowded.
And this gets to the absolute core of the problem today. Just because a cable system is squeaky clean in that narrow airplane band, that doesn't mean it's not leaking like crazy at other frequencies. And as our wireless world grew, that blind spot turned into a massive issue.
Here's why. The radio spectrum is a finite resource, right? There's only so much of it. So to make room for all of our modern wireless gadgets, the government started taking the old frequencies that were used for broadcast TV, the UHF channels, and they resold them for new stuff.
And a perfect example of this is the 700 megahertz band. Frequencies that used to be home to TV channels 52 through 69 are now the absolute bedrock for things like our LTE cell phone networks and the critical communication systems for police, fire, and ambulance services.
And this big shuffle of the airwaves created a completely new kind of interference problem, one that those old rules were never, ever designed to catch. So here's the crucial thing to understand. When a cable has a leak, it doesn't just leak on one channel. It radiates noise across its entire spectrum. It basically becomes a rogue mini broadband transmitter, just spraying all those TV and internet signals out into the air. And now, those signals can land directly on top of the frequencies our cell phones and first responders depend on.
So suddenly, the scope of the problem is just so much wider. It's not just about airplanes anymore.
Now, cable leaks can mess with your LTE or 5G service, causing dropped calls or slow internet. They can interfere with a firefighter's radio in an emergency. It even affects amateur radio operators and people who listen to shortwave radio.
And this right here, this is the smoking gun. This is a real-world picture from a spectrum analyzer. You see all those jagged peaks? That's a cable company's digital signal leaking out into the air. And look right where it's landing. Smack dab on top of the frequencies used by Verizon's LTE network and public safety radios. They're trying to occupy the exact same piece of sky.
So this discovery has basically forced a whole industry to completely rethink how they go about hunting for these hidden, invisible threats. What this means is that the old way of doing things just doesn't cut it anymore. Focusing only on that low-frequency airplane band means you could be completely blind to a huge leak happening at a higher frequency. The new reality demands high-frequency monitoring that sweeps across the whole spectrum, especially that 700 MHz band, to get a real picture of a network's health. And as engineers started using this new gear, they came to a pretty sobering conclusion. Field tests are proving again and again that our cable networks just aren't as tight, not as perfectly sealed as everybody thought they were. This problem of high-frequency leakage is way more common than anyone realized.
Which kind of brings us full circle. We think of our wired and wireless worlds as being totally separate, but they are deeply, deeply connected. A tiny flaw in a physical cable hanging on a telephone pole can actually impact your ability to make a 911 call on your cell phone. So it really leaves us with this question. As our wireless world gets more and more crowded, just how important is the health of the wired world hidden all around us?